Okay, I know this isn't exactly the most original video idea, but after studying game dev for the past few months, I wanted to challenge myself to complete a project. And while I don't think I can finish it in 1 or 2 days, I'm going to try my best to finish it in a week. Let's see how it goes. To start, I'm using the GLFW library to handle window creation. And within a few minutes I had a blank window. Next up was actually rendering something in the window. Rendering in OpenGL requires a lot of tedious setup, including things like writing, compiling, and linking shaders, and dealing with buffer objects. But after you get all of that set up, everything is pretty straightforward from there. And after about 2 hours of work and a couple hundred lines of code, we have a red square. The next step was to turn our red square into a red cube, and doing so is going to require some matrix transformations. A few weeks ago, I spent a couple days learning the basics of linear algebra, so I'm going to be using my own math library to do all of the necessary calculations. And after spending a few hours fixing some annoying camera bugs, we have a red cube. Getting textures to work was pretty easy, but after struggling to create my own textures, I ended up just pixelating images of grass and dirt. It's not perfect, but I think it turned out okay. Now that I could render textured cubes, it was time to start creating chunks. I initially tried to render each cube one by one, but the performance was terrible, so I decided to go with instance rendering. With instance rendering, the performance was much better, and here I'm rendering just over 650,000 cubes. After I had chunk rendering working, I wanted to start working on terrain generation with noise. If you don't already know, noise is what voxel-based games use to procedurally generate terrain height maps to give the terrain a more realistic look. And here's a few failed attempts at getting that to work. After a while of messing around, I finally had something that was starting to resemble terrain. And after adding in a proper grass texture, the results were starting to look pretty cool. At this point, I realized that instance rendering was not the best way to go, and in order to generate larger worlds, I was going to have to rewrite the rendering code. As you can see from this wireframe, all of the cube faces on the inside of the chunk are still being rendered even though you can't see them. This is really bad for performance, so I needed a way to fix that. By looping through all of the blocks in the chunk and checking each surrounding block, I could determine which faces needed to be drawn. And after a few failed attempts, I now have a clean chunk being rendered. Now when you look at the wireframe, you can see that none of the faces on the inside are being drawn. With that implemented, I can now render much larger worlds without any performance issues. Next up was making the world infinite. This was done pretty easily by keeping track of the camera's position and expanding the world as the camera got closer to any chunk edges. As you can see, as the camera moves to the right, the world expands in that direction, and the chunks on the left get removed as the camera moves further away from them. And what's an infinite world without some trees? At this point, we have an infinite world, but we can't actually do anything in it, so it's time to add in some block breaking. This was actually easier than I thought it would be. By taking the camera's position and direction, I could easily check what was in front of it, and if there was a solid block there, I could just remove it. And shortly after, I got block placing to work by doing some extra calculations to determine which face of the block the camera was looking at, and placing a block on top of or next to that face. The last thing I wanted to do was hack together a quick physics system so I could move around in my newly created world. Simulating rigid body dynamics is by far the easiest part of any physics system. By using Newton's second law of motion, we can easily calculate the acceleration and velocity of an object. And once we do that, we can apply a constant gravitational force every frame, and we have gravity. Collision detection is much more complex, but since we're only dealing with cubes that don't rotate, the collision tests are really simple. And here you can see the physics system in action. With the physics implemented, I think that my Minecraft clone is pretty much complete. I know it's definitely not the most well-optimized or feature-filled clone, but considering it's my first completed game dev project, I think it's a pretty good start. If you'd like to see me add more stuff, let me know in the comments. And if you want to take a look at the code, a link to the GitHub repository will be in the description. Thanks for watching.